Thank you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem that appeared in the CSIR National Eligibility Test held in the month of December 2023. This question is from the section Real Analysis and it is related to the concept of interior point of a set. This question is placed in part C, which is a multiple select question. There can be more than one answer and it carries 4.75 marks. The question ID is 704090. This question is suitable for all these examinations. Right. The given question is, let P be a function from R square to R defined by P of the ordered pair x comma y is equal to x. Which of the following statements are true? We are given four options. Option 1, let A1 be the set of all those ordered pairs which satisfy x square plus y square less than 1. Then, for each gamma belongs to P of A1, there exists a positive real number epsilon such that the open interval gamma minus epsilon to gamma plus epsilon is contained in P of A1. It means to say that for each gamma belongs to P of A1, we find an epsilon neighborhood of that gamma which is entirely contained in P of A1. It amounts to say that gamma belongs to P of A1 is an interior point of P of A1. Option 2. In a similar fashion, A2 is the set of all ordered pairs x comma y such that x square plus y square less than or equal to 1. And this time, gamma belongs to P of A2. There exists a positive real number epsilon such that gamma minus epsilon to gamma plus epsilon is contained in P of A2. Option 3. Let A3 is equal to set of all those ordered pairs such that x comma y such that xy the product is equal to 0, and similar statement as of options 1 and 2. In the case of 4, A4 is the set of all those ordered pairs x comma y such that xy is equal to 1, ditto as above. Let's now discuss the solution of the problem in detail. We have a function p from r square to r defined by p of x comma y is equal to x. What is this? It is a projection map. It's a projection map on x-axis. Agreed. Now we call on option 1. Let A1 is set of all ordered pairs x comma y belongs to R square such that x square plus y square less than 1. Right. Then we have to show that gamma belongs to P of A1 is an interior point of P of A1. Now we have A1 as above, right? And that is x-axis, y-axis, and this is a x square plus y square less than 1, all ordered pairs which lie in the circle, not on the circle. Open neighbor of 0, unit disk, open unit disk. Right. Now, P of A1 is equal to P of these ordered pairs x comma y, where x comma y belongs to R square, satisfying x square plus y square less than 1. So, what is P of x comma y? It is x. But for various points of this open disk, the x coordinates we have to collect. The x coordinates will be from -1 to +1. Right. So, this is the set of all those x belongs to R such that P of xy is x. X comma y belongs to R square and x square plus y square less than 1. What are those? All those x belongs to R? The x coordinates of the ordered pairs that lie in the open unit disk. That is the open interval -1 to +1 on the real axis, on the x-axis. Right. Now, what is P of A1? Open interval -1 to +1. And what is this? Is an open set. For every gamma belongs to -1 to +1, gamma is an interior point of this one. Therefore, there exists an epsilon greater than 0 such that the neighborhood with the center gamma and radius epsilon is entirely contained in P of A1. That is precisely the open interval gamma minus epsilon to gamma plus epsilon contained in P of A1. For each gamma belongs to P of A1, P of A1 is -1 to +1. We have gamma belongs to -1 to +1. And gamma is an interior point of -1 to +1 because it is an open interval, and so it is an open set. Right. So, there exists an epsilon greater than 0 such that the neighborhood with the center gamma and radius epsilon is entirely contained in -1 to +1. That is, the neighborhood center gamma and radius epsilon is open interval minus gamma minus epsilon to gamma plus epsilon contained in P of A1 for all gamma belongs to P of A1. Thus, option 1 is true. Right. We move to the next slide. For the next option, option 2. Let A2 is set of all ordered pairs x comma y such that x square plus y square less than or equal to 1. Right. So now we have A2 is ordered pairs x comma y belongs to R square such that x square plus y square less than or equal to 1. X-axis, y-axis, it is the circle x square plus y square is equal to 1, and all ordered pairs x comma y belongs to R square such that x square plus y square less than or equal to 1 means all points that lie inside and on this unit disk. Right. So, P of A2 is P of these ordered pairs, and the P of ordered pairs is x only. P of x comma y is x only, where x comma y belongs to R square and x square plus y square less than or equal to 1. All x coordinates of all the points that lie inside and on the unit circle. Who are they? This is the closed interval -1 to +1. Now, is it true for each gamma belongs to P of A2? Does there exist a neighborhood which is entirely contained in P of A2, that is -1 to +1 closed interval? No. Because 1 belongs to P of A2, we cannot find an epsilon greater than 0 such that 1 minus epsilon to 1 plus epsilon is entirely contained in -1 to +1. It's not possible. It's not possible for any epsilon greater than 0. So, assume that for each gamma belongs to P of A2, that is, for each gamma belongs to the closed interval -1 to +1, there exists a positive real number epsilon such that the open interval gamma minus epsilon to gamma plus epsilon is entirely contained in P of A2, that is the closed interval minus 1 to plus 1. And each point gamma belongs to minus 1 to plus 1 is an interior point of P of A2, that is minus 1 to plus 1 closed interval. This is what it says, if you assume that. But this is not true, since gamma is equal to 1, comma minus 1, the endpoints are not interior points of P of A2. Right? So therefore, the option 2 is not true. Option 2 is not true. Right, we move to option 3. Now this time, A3 is set of all ordered pairs x comma y belongs to R square. The product xy is equal to 0. We have this one. So, what are all those ordered pairs such that the product x comma y, x into y is equal to 0? This is a set of all ordered pairs x comma 0 belongs to R square, x belongs to R. That is precisely the points on x-axis. Union, the integral, the interval, the ordered pair 0 comma y, is an ordered pair 0 comma y belongs to R square, y belongs to R. That is, this is the y-axis. This is the y-axis. Now, the x-axis, y-axis. All points on x-axis, all points on y-axis. Right. Now, P of A3 is P of all the ordered pairs x comma y belongs to R square. The product xy is equal to 0. So, P of A3, the projection, if you take x comma all, for all x comma 0s it is x. For all 0 comma y, the projection is 0 only. Right. So, it is only x belongs to R, xy belongs to R square, xy is equal to 0. That is all points on x-axis. That is R. So, P of A3 is R. What is R? R is closed, is open. Therefore, every point of P of A3, therefore every point of R is an interior point because R is open. Therefore, for each epsilon greater than, for every gamma belongs to P of A3, that is equal to R, there is a positive number, epsilon says that the neighborhood with center gamma radius epsilon is entirely contained in P of A3, that is equal to R. So for each gamma belongs to P of A3, we have gamma belongs to R. Now gamma is an interior point of R because R is an open set. So there exists an epsilon greater than 0 such that the neighborhood with center gamma and radius epsilon is entirely contained in R. That means that is the open interval gamma minus epsilon to gamma plus epsilon is entirely contained in P of A3, that is equal to R. For all gamma belongs to P of A3. Thus, the option 3 is true. Agreed. Right. We move on to the next option, option 4. A4 is equal to all ordered pairs x comma y belongs to R square such that the product xy is equal to 1. So that is A4. So what is this? Xy is equal to 0, xy is equal to 1, xy is equal to 1 is a rectangular hyperbola. So therefore all ordered pairs x comma y belongs to R square, xy is equal to 1. A set of all points on the rectangular hyperbola. This is the rectangular hyperbola. Now, as x tends to 0 plus from positive side, as x tends to 0 from positive side, y tends to infinity. As x tends to 0 from left, y tends to minus infinity. Therefore, x is equal to 0 is not included. And for every x, there is a y. So, what is A4? P of A4 is P of x comma y, x comma y belongs to R square, xy is equal to 1. That is, the set of all x belongs to R, x comma y belongs to R square, xy is equal to 1. But in this 0 is not included. That is, minus infinity to 0 and union 0 to infinity. X is equal to 0 is not included. Right? If you take x is equal to 0, there is no y. Right? So 0 is not included. And each is an open set, open interval. Each is an open interval, therefore it's an open set. The union of open sets is again open, therefore this is open. Therefore, for each gamma belongs to P of A4, we have gamma belongs to this union. Now gamma is an interior point of this union because this union is an open set as it is the union of the two open sets. Therefore, gamma will be an interior point. Therefore, there exists an epsilon greater than 0 such that the neighborhood center gamma and radius epsilon is entirely contained in the union of these intervals. That is, the neighborhood is the open interval. Gamma minus epsilon to gamma plus epsilon is entirely contained in P of A4, that is the union of the intervals. For all gamma belongs to P of A4. Thus, option 4 is also true. Summarizing all the options, the answer to this question is options 1, 3 and 4. That is the detailed discussion of the solution of the given problem from the section real analysis, which is related to the concept of interior point of a set. And I rate this question as a very, very easy question. And once you find out what is A1, A2, A3, A4, then apply the projection map on that on x-axis. Then the P of AI, I is equal to 1, 2, 3, 4, whether it is an open set or not, that matters. That's the only question. But that is given in terms of the epsilon and the open neighborhood and so on and so forth. That is the detailed discussion of this question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We hope to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.